Okay, the fourth and last problem on the exam is the boy twirling a 15-pound bucket of water in a vertical circle. If the radius of the path is 4 feet, determine the minimum speed the bucket must have when it is overhead at A so that no water spills out. Neglect the size of the bucket in the calculation. Hint, give a force diagram at the top at A for the bucket, write down the relevant dynamical equation, and incorporate the condition of no spilling. All right, so we'll call this one here the twirling bucket of water. So here, I'll just go ahead and draw a little picture of the bucket here, like this. It's going that way. This is 4 feet, a little more than a meter, and no water spilling. And this thing here is 15 pounds. All right. So now the force diagram, we have here, this is the rope. So we have the T, the rope, and we have the weight, mg. So that's it. So that means we have the case where the water doesn't spill, and that means when the T is going to be slack, where this is just slack, all right? Just making it with no spill. There's no tension in the rope. So here, let me just write the equation down to get partial credit here in case I make a mistake. Say T plus mg, that's equal to ma. And the ma is mv squared over r because it's the acceleration due to circular motion. All right, so that's important to have that down. Make sure you get partial credit. So then when you have the t equal to 0, you're going to get mg equals, t is going to be 0, so you'll have mg is equal to mv squared over r. So you notice that the masses cancel, and you get g is v squared over r. We saw in the class this v squared is gr coming together dimensionally in various problems. So that means here v is the square root of gr. And now we can put in the numbers. This is 32 feet per second squared. The units are going to help me make sure I'm not making a mistake, because see, this is going to be feet squared over second squared. Take square root, get feet per second. So this is going to be the square root of 128. So when you take the square root and you get like close to 11, because 11 times 11 is 121, 12 times 12 is 144, so it's going to be more than 11. Work this out, 11.3 feet per second. And going for two significant figures, we could say 11 feet per second. So that's, as I said, 3 feet is close to a meter. So that's like, you have like 12 feet would be like 4 yards, 4 meters per second. That would be the metric equivalent. Okay, that's finished the exam.